Welcome back to Neural Intel. Today, we're going to be looking at some groundbreaking research on how large multimodal models reason,
Oh.
or as they're known, LMMs.
Yeah, those AI models that can work with both text and images.
Right.
It's really like getting a glimpse inside how the AI thinks.
Uh-huh.
And what's so cool is this research, it goes beyond just whether these models, get the right answer.
Yeah.
It's about the quality of their reasoning, how robust it is, and whether it's efficient.
That makes sense. So we're talking about the paper MME-CoT, benchmarking chain of thought in large multimodal models for reasoning, quality, robustness, and efficiency, which is
Yeah.
a bit of a mouthful, but I promise the findings are worth it.
Oh, they definitely are. This research uses what's called chain of thought prompting,
Okay.
which basically encourages the model to break down its reasoning into these logical steps.
So instead of just giving an answer, it's like we're asking the AI to show its work.
You got it. And that's where MME-CoT comes in. It's a specialized benchmark that really evaluates how effectively these models use this chain of thought reasoning.
Okay.
And they do this across 6 different domains.
6.
Yep. Math, science, OCR, logic, space-time, and general scenes.
Wow, that's pretty comprehensive.
It is. They really wanted to cover a lot of ground.
So we've got the LMMs, we're using this chain of thought prompting, but how do we actually know if an AI is reasoning well? I mean, it seems kind of subjective.
It's a great question, and that's where those 3 key areas you mentioned earlier really come into play.
Right, quality, robustness, and efficiency.
Exactly. Let's start with quality.
Okay.
So let's say the model is working on a math problem.
Hmm.
We don't just want the right answer.
Right.
We want to see the logical step-by-step solution.
No AI shortcuts.
Exactly. No magic, no pulling answers out of thin air.
I like it.
To check this, the researchers, they use these metrics called precision and recall.
Uh-huh.
Precision is about making sure each step in the AI's reasoning is accurate and actually relevant to the problem,
Okay.
while recall ensures that the AI hits all the important points in its thought process.
So it's like we're looking for a complete and accurate chain of reasoning.
That's a great way to put it.
Perfect. Now, what about robustness?
Okay, so robustness is about how well the model's reasoning holds up across different kinds of tasks.
Does thinking step by step always make sense?
Right, and this is where it gets interesting. The research actually found that in some cases, this chain of thought prompting, it can actually hurt performance on tasks that are more about perception.
Really? So thinking too much can be bad for an AI?
It seems that way. It looks like forcing the model to go through this complex thought process can sometimes make it overthink a simple task.
Huh. So it's like overanalyzing a simple question and getting tripped up.
Exactly. It shows how AI still has a lot to learn about knowing when to use different thinking strategies.
It's not just about making AI smarter,
Right.
but smarter about how it thinks.
That's it. And that brings us to that third key area, efficiency. It's great if an LMM can generate a long chain of thought, right?
Sure.
But is it doing it efficiently? Is it spitting out a bunch of irrelevant information? Are those reflection steps where it checks its own work actually helpful?
It's almost like we're making sure the AI isn't wasting its time.
Yeah, and not wasting mental energy on irrelevant stuff.
Makes sense, but how do they measure something like that?
They use a couple of metrics. One is called relevance rate,
Okay.
which basically looks at how much of the content the model generates actually contributes to the final answer. And then there's reflection quality, which assesses whether the AI's self-checking is actually getting it closer to the right answer.
So are those reflection steps actually making a difference?
Exactly.
Okay, so they've got their criteria, but which LMMs did they actually test?
They had a whole bunch of models, both open source and closed source.
Okay.
In the open source group, there was Mulberry, Eleva, Mini CPMV, Intern VL2, Q Quin2 VL, Virgo, and QVQ.
Wow, that's quite the lineup.
And of course, for comparison, they had to include the Big Kahuna, the closed source, GPT-4o.
Sounds like a real battle of the AI brains. So what were some of the most interesting things they learned?
Well, one of the big surprises was that the models with built-in reflection capabilities did really well in terms of the quality of their chain of thought.
So being able to double-check their own work makes a big difference.
It seems that way. That self-verification is really powerful.
It's like how we reread emails before hitting send.
Exactly. But they also found that even these models, the ones that could do this deep reflection, they could still get sidetracked.
Oh, no.
Yeah, sometimes they generate a ton of information that was totally irrelevant to the task at hand.
So even with reflection, they can still go down those mental rabbit holes.
It seems so. More like us than we thought, maybe.
Maybe AI is more human than we think. What else did they find?
They also discovered that a lot of those reflection steps were actually useless.
Really?
The AI would go through the motions of checking its work, but those checks didn't actually improve its accuracy at all.
Wow. So it's not just about checking your work, but checking it in a way that actually leads to better results.
That's a great point. It suggests that AI still has a long way to go when it comes to true self-awareness and self-correction.
So even these advanced models still have some blind spots. That's a pretty important takeaway.
It really is. It highlights the need for more sophisticated reflection mechanisms in these models.
Okay.
They need to not only be able to spot potential errors, but also figure out how to actually fix them.
Right, so quality, robustness, efficiency. Were there any specific examples in the research that illustrate these concepts?
Absolutely. There was this one task involving spatial reasoning.
Okay.
They showed an LMM a series of pictures of a car moving along a road.
Uh-huh.
The model had to put the images in the correct order.
So basically reconstructing the car's journey.
Exactly. Seems pretty simple, right?
Yeah, it does.
Well, one model actually struggled with this.
Really?
It was a long chain of thought model with reflection and everything. But it got so hung up on these irrelevant details.
Like what?
Like describing the color of the car or what kind of trees were in the background.
Who's focusing on all of the things?
Totally lost in the weeds. And the craziest part is its reflection steps didn't help at all.
Oh, no.
It kept checking its work,
Uh-huh.
but those checks didn't make it reconsider its focus.
It was confidently wrong, even after double-checking.
That's a great way to put it. It really shows how important it is for the AI to focus on the right things when it's reflecting.
Okay, so it's not just about being able to reflect,
Right.
but about reflecting on the things that actually matter.
Exactly. And that leads to another interesting point.
What is it?
They found that sometimes even those long chain of thought models, even the ones with reflection,
Yeah.
they didn't always include all the necessary steps in their reasoning.
Wait, so they could get to the right answer,
Uh-huh.
but miss some of the important points along the way.
It seems that way. It suggests that maybe they're relying on some kind of shortcut or intuition to get to the solution.
That's not very transparent.
It raises questions about how reliable their reasoning really is.
We need to be able to trust that they're getting to those answers through logic, not just luck.
Absolutely. This research has given us so much to think about, especially when it comes to those three key aspects of AI reasoning: quality, robustness, and efficiency.
It's like we're starting to peel back the layers of how these LMMs really think.
Exactly. And with each new discovery, we're getting closer to understanding how to make AI even more intelligent, insightful, and reliable.
Well, this has been a fascinating look into the inner workings of AI reasoning. It's really opened my eyes to the challenges and the incredible potential of this field.
I'm glad to hear it.
I'm definitely eager to see what new breakthroughs emerge in this rapidly evolving field.
Me too, and there's so much more to explore.
Right.
But I think we've covered a lot of ground in this first part.
Yeah, we have.
So let's take a break here, and then we'll come back and dive into some more specific examples.
Sounds good to me. We'll be back in just a moment with more from our deep dive into AI reasoning, right here on Neural Intel.
It really makes you wonder, what separates those effective reflection steps from the ones that don't do anything?
Yeah, it's almost like the AI needs this metacognitive layer,
Uh-huh.
a way to not just understand what it's thinking,
Right.
but how it's thinking about it.
That's a great way to put it. And that's why this research is so valuable, because it really highlights those areas where AI still has room to grow.
Right. It's like pushing the boundaries.
Exactly. So it's not just about, saying how amazing AI is,
Yeah.
but also being realistic about its limitations.
And using those to guide future development.
Precisely. That kind of critical analysis,
Uh-huh.
it's essential for the field to keep moving forward.
It's like a roadmap.
Exactly. Okay, so let's zoom in on some specific findings.
Okay.
You mentioned earlier that they tested a bunch of different LMMs.
Right.
So how did they actually do in this MME-CoT benchmark?
Were there any that stood out?
Oh, for sure. In terms of overall chain of thought quality,
Mm-hmm.
Kimi K1.5, a closed source model, came out on top.
Interesting.
It consistently showed high precision and recall, meaning it generated these accurate and comprehensive reasoning steps.
So Kimi K1.5 is the reigning reasoning champs for now.
At least for now.
What about the open source models?
Well, among those, Qwen2 VL72B really impressed me.
How so?
What's cool is it actually beat some of the larger open source models.
Oh, wow.
And it wasn't even specifically designed with reasoning in mind.
So size isn't everything in AI.
Not always.
What about the models that were designed for reasoning, like Mulberry and Intern VL2 MPO? How did they perform?
Those showed a lot of promise,
Okay.
especially when it came to robustness.
Uh-huh.
Intern VL2 MPO actually improved its performance on those perception tasks when using chain of thought. And that was true for both its 8B and 78B versions.
Interesting. So it's like it knows when to really think and when to just go with its gut.
Yeah, it's less likely to fall into that overthinking trap we talked about earlier.
What about Mulberry? Did it have any quirks?
Mulberry, it was a character.
Okay.
It loved to give these super long and detailed explanations,
Mm-hmm.
even when a simple answer would have been enough.
It's like that friend who always have to over-explain everything.
Exactly. But on a more serious note, that kind of tendency, it
Yeah.
can really impact efficiency.
Oh, for sure. And that reminds me,
Uh-huh.
didn't the research also find that even those long chain-of-thought models,
Yeah.
the ones that can do all that reflection,
Right.
sometimes they didn't cover all the necessary steps in their reasoning.
That's right. Sometimes they'd get to the right answer,
Uh-huh.
but they'd miss some of the key points along the way.
How is that even possible?
It's like they're taking some kind of mental shortcut, Like they're using intuition instead of that clear step-by-step logic.
It's like peeking at the answer key before showing your work.
Exactly. Not ideal if you're trying to test reasoning skills.
Right. And it kind of undermines our trust in their thinking.
It does. We need to know they're not just getting lucky, but actually thinking things through.
This all brings us back to efficiency, doesn't it? Making sure the AI is staying on track and not wasting time.
Absolutely. And that's another area where the research had some interesting findings.
Like what?
They saw that even those long, reflective models, they
Yeah.
could still get distracted.
Oh no, not those rabbit holes again.
It happens to the best of us, right?
I guess so. But seriously, how can we help these models stay focused?
Well, it's clear that we need techniques to improve their focus, even when they're capable of these really complex thought processes.
More focus, less rabbit holes.
Exactly. Now, what about those reflection steps? Any tips on making those more effective?
Yeah, I'm curious about that too.
Well, this is where it gets really interesting. They found that a lot of those reflection steps
Uh-huh.
were actually useless.
What do you mean?
The AI would go through the motions of ep in its work,
Okay.
but it didn't lead to any of actual improvement in accuracy.
It's like when I try to proofread my own writing.
Right.
Sometimes I just can't see the errors.
It's like AI has the same blind spot.
Exactly. So how do we fix that?
Well, it points to the need for more sophisticated reflection mechanisms. Like they need to not just spot errors, but also understand how to actually fix them.
So like having a good editor who can give you suggestions.
That's a great analogy. And I think this research has given us some good ideas about how to get there.
This is all so fascinating. We're really starting to understand the strengths and weaknesses of these models.
We are. And that understanding is crucial for building better AI.
So what are the practical implications here? How can we actually use these findings to build better AI systems in the future?
I think this research has the potential to change the way we think about AI development.
In what way?
It's not just about building bigger models,
Right.
but about figuring out how to make them reason better.
More efficiently and more reliably.
Exactly. It's like shifting from brute force to finesse.
I like that. So it's about developing systems that are intelligent, insightful, and trustworthy.
That's it. And these findings give us a roadmap to get there.
I'm really excited to see where this all leads. It feels like we're on the brink of a major breakthrough.
I agree. It's a really exciting time to be working in this field.
Absolutely. But we've covered a lot of ground here.
We have.
So let's take a quick break,
Okay.
and then we'll dive into some specific examples of how these LMMs handled those tricky reasoning tasks.
Sounds good to me.
We'll be back in just a moment with more from our deep dive into AI reasoning, only here on Neural Intel. Welcome back to Neural Intel. We're wrapping up our deep dive into how these large multimodal models reason, those LMMs we've been talking about.
Right.
We've talked about the strengths and weaknesses, and now I really want to see these concepts in action.
Okay, so remember that visual question answering task?
You mean the one where the model had to decide which food was healthier?
Yeah, that one.
And it ended up overthinking and just not answering at all.
Exactly. That's a great example of how even these advanced LMMs, especially those with long reflective chain of thought reasoning, they can still get sidetracked.
It's like they have a really strong inner critic.
Like a critic that sometimes gets a little carried away.
That's a great analogy. So how can we help the AI, guide that inner critic?
That's a key question for researchers.
Right, because we want the AI to be thoughtful,
Uh-huh.
but not to the point where it just can't make a decision.
We don't want analysis paralysis.
Exactly. So any other examples from the research that show this?
Oh, there's another one that really comes to mind. The researchers gave an LMM a science problem.
Okay.
It involved a diagram of a pulley system.
A classic physics problem.
Right. And they asked the model to figure out how much force was needed to lift a certain weight.
Did the LMM solve it?
Well, one model did something really interesting. It got the physics principles, right?
Mm-hmm.
But then it got stuck trying to calculate all the angles and distances in the diagram.
Was that really necessary?
It wasn't. The diagram wasn't even drawn to scale.
So it was trying to be way too precise.
Exactly, like using a microscope to measure ingredients for a cake.
Sometimes you just need to estimate.
Right, and the funny thing is,
Get that.
this model went through all these reflection steps, checking and rechecking its calculations, but it never stopped to think about whether all that precision was actually helpful.
It was missing the forest for the trees.
Exactly, and it shows another challenge we face.
What's that?
Building models that can adjust their level of detail depending on the task.
So it's not just about reasoning,
Right.
but about knowing how to reason strategically.
That's a great way to put it. Knowing when to be super precise and when to be more flexible.
AI reasoning isn't just a technical challenge, it's
No.
a cognitive one.
Exactly. And that's what makes this whole area of research so exciting. It's not just about better algorithms.
Yeah.
It's about figuring out how thinking works and how to create that in AI.
It's like we're trying to create artificial minds.
In a way, yes. And research like this is showing us how to get there.
This has been a really amazing deep dive.
It has.
I'm leaving with a lot to think about.
That's what we like to hear.
It's made me realize the incredible potential of AI, but also all the challenges that still lie ahead.
It's a journey of discovery, that's for sure.
Absolutely. And for our listeners, if you want to learn more about this, be sure to check out the full research paper
The link is in our bio.
and subscribe to Neural Intel for more deep dives into the latest AI and ML research.
We'll be back soon with even more amazing insights from the world of AI. Until then, keep those neural pathways firing.
And keep those reasoning muscles flexed. See you next time on Neural Intel.